Okay, so what I want to do, obviously, as we most often do, is go ahead and lead with some questions. But rather than just kind of take them indiscriminately, I want to take them an assignment at a time, okay? So I want to start with the problem set and handle any questions you might have lingering on the problem set. And I need you to know that I've built in a little bit of additional time in this evening, knowing that normally there are more questions tonight than there are in some other nights. So what kinds of questions might you like to ask with respect to the problem set using CAPM WACC? Well, I know that's not the truth. I'm absolutely aware that there are more. Okay, so let me ask you a question then. What's the primary difference? I don't mean in the numbers of outcome, but the conceptual difference between the value that you get when you assess this firm's value as a function of an investor's expected rate of return, which I think I gave you at 20%, versus the discount rate that we can calculate, which I believe was rounded to 9.4 or 9.39 something. What's going on there? What's driving that difference? David, any ideas?
Sure. I would say that the investor required rate of return is oftentimes based off of kind of perception and estimate rather than numbers. And when you talk about the weighted average cost of capital, it's all formulaic and based on actual costs. So they're always, not necessarily always, but in this case, they're very different. Mainly because of...
They're radically different in this case,
yeah,
right? Yeah.
Right. And I would say that's the biggest difference in the both of them conceptually. Investors oftentimes don't have numbers that they're basing it off of, and that's what the weighted average cost of capital is all numbers based.
Yep.
Off of cost.
That's a really good way of putting that, David. So think about this. Jason, I don't know if you're much of an investor or not. I don't know if you like to play the markets or invest in companies. Do you?
Not so much. I'd love to. I just stick with what I know.
So you're the guy. You're the one exactly that I want to talk to. So if you saw a company out there, maybe it's Pasquinel Enterprises, and you kind of like the story of the company. Maybe Taylor, the investment advisor representing the firm, has talked to you about it, and you like the company. Are you likely to take a rigorous look at the numbers behind this, or are you likely to just decide whether or not you like the story?
Probably the story, unfortunately. But I'd probably be much more hesitant, to be honest. I really, before I put money onto anything, I would want to make sure that I know the story, and I probably know. I rely on other people I know as well who maybe have taken more time to do that homework and figure things out. And if I had the time to do the homework, then that's one thing, but more than likely.
Well, that's a fair response. And I think that's a response that most investors would give, except for professional investors, except for institutional investors and the like. So this disparity between an investor that thinks there should be a 20% rate of return, which maybe is just an investor that's kind of what they'd like to get, versus having critically, numerically, as David tells us, assessed the company's cost of capital. That's not an uncommon scenario. In fact, I'm dealing with someone right now who's a graduate of this program of the last 3 or 4 years. And he's getting ready to buy a company. It's not a big company, but it's, he's going to spend some millions of dollars on the deal. And so he brought me in to tell him whether or not what it was being asked for was realistic. And I ended up saying, well, from the perspective of the capital structure, yeah, it's probably realistic. I might be a little concerned about making an investment in the aftermath of COVID anything and not knowing what we don't know, right? But absent that effect, it may have been realistic. I'm just not sure that he's being realistic. And so this has begat about a 3-week dialogue about how you think about these things. So in this case, if the actual cost of the company's capital components, and when I say cost, I'm talking about opportunity cost, so a very market-derived structure and value, if that's based on a 9.4% discount rate, and an investor thinks they're going to be able to get a 20% return, is there any credibility to this? Is it a rational transaction that we're looking at? What do you think? What do you think, Mario?
I was going to say it's really unrealistic, and then it's almost double what you should be expecting, right?
I tend to agree with you.
Half of what you should be expecting.
Yeah, I tend to agree with you. Okay. In order to use an investor return expectation at 20%, we either have to have a capital cost structure of near that, or that investor must be bringing something to the table more than just money, just more than passive investment. Maybe they're bringing relationships, maybe a network, maybe they're bringing innovation, or maybe they bring something else that's going to improve the revenues, which improve the EBIT, which then lets us have a better overall return structure. So that's what's at the heart of some of that disparity. Let me walk through and make sure that we understand how the numbers on the front page came about. And I think most of you do understand this, but I know a couple of you don't. And so let's think about them for a minute. I'm going to share my screen. Are you all looking at my problem set now? Good. All right. So you've got a couple of choices when it comes to setting something like this into a worksheet. You can just type all the numbers in. But when you do that, you run the risk of what I refer to as quantitative fidelity, or problems with quantitative fidelity. Let me give you an example. I'm going to look at this and say, well, our first firm-oriented cash flow, or the one that's coming from the firm's operations, that's not $20 million, is it? Where's that $20 million coming from, Lisa, in year 0 or 2015?
So where's that coming from?
Yeah. Is that a $20 million loss that the company had from its operations in year 0?
Would it be what it's purchased for?
That's exactly right. So it's an investor's investment or cost, right? And if that investment happens at time 0, then it's being discounted at whatever discount rate, but to the exponent of 0, which means that it might as well have just not been discounted at all, right? So if Taylor's willing to pay $20 million for this, then we see that $20 million amount sitting here as a cash flow, not the firm's cash flow, but the investor's cash flow at time 0 right now. And you're told in our story that the company is expecting to lose $5 million for each of 3 years. I say you're told in our story. There's not a lot of story up here, though, is there? Where do you get most of this information?
There's a lot in the footnotes as well.
In the footnotes. All of the secrets that we hide in plain sight. Okay? I have put things in footnotes at times that I knew were absolutely egregious, outlandish, and inflammatory, knowing full well that the investor would not see them. Okay? It just still blows my mind. Nonetheless, you're given this information, and then I've typed it in here for you, of course. And then you're told that there's no change in no growth in that revenue. So $5 million loss in year 1, $5 million loss in year 2, $5 million loss in year 3. And you could just type those in, but I would recommend not doing so. I would recommend typing in the first one of them, and then for years 1 through 3, I would grow that first $5 million loss at a 0% rate. So it doesn't change. It's not growing if it's a 0%. And then you're told down in the footnotes that we have a $3.5 million. Maybe you're told it up in the story above as well. We have a $3.5 million cash flow expectation in year 4. Good for us. We've stemmed the bleeding. And beyond that, for the next 4 years, that's going to grow at 35%. And here's where some of the problems start to take place. Some people would simply type in these next few numbers for years 5, 6, 7, and so on. But if we do that, then we start losing some fidelity because we're rounding. Yes, 3.5 million times 1.35 is 4,725,000. It's a nice even number. And then it is 6,378,750. It is a nice even number. And then it's not 8,611,312.5. There's stuff that keeps going to the right of these decimal places. And in the next year, it becomes even more different and so on. So rather than type the numbers in, you build a model using the various growth rates that I'm giving you here in the information. And you'll find that if you did that, it would replicate all of these values. But there's one value that I haven't even put on here. Which value is that? You see it? So I'm giving you growth rates for years 1 through 3, 4 through 8, 9 through 13, and 14 plus. Do you see year 14? You don't. You don't. So you've got to calculate year 14, which means you're going to take year 13, whatever that number calculates as, and you've got it in the cell. You didn't type it in. It's there formulaically. And then you grow it at 4% to give you year 14. You know there's a year 14 because I've told you there is. Okay? So there's a lot going on here. And then rather than type in the numbers in this column, we're going to calculate them by taking the number in this column and then discounting it by the discount rate. And in this case, we use the discount rate of 20%. Big one, right? And this one is this 5 million discounted again at 20%. Notice that every year, even though we're using the same number and we're discounting at the same rate, the present value of that number is going down in a big way. Michael, why is that? You're on mute, Mike.
Can you repeat that? I missed the initial question, the first
Sure.
part of that.
Notice here that we've got the same number in year 2 that we did in year 1. Is being discounted at the exact same rate, 20%, but it ends up with a completely different, a very different number. Why is it different? Why is it so different? Why is present value in year 1 different than present value in year 2, given that I started with the same cash flow and the same discount rate?
Because for year 1, you start at 0?
No.
I mean, 0, you start, I don't know.
It's okay, Mandy, do you have any idea?
The n value, so it's dividing it by something to the nth power, and the n is the year. So
Yeah, that n, or that exponent's dynamic, right? So we have another year worth of discounting at not a small rate, at 20%. So even though we have the same input values for the cash flow and the discount rate, that n, or that exponent in the equation, is what's giving us the compounded effect, isn't it? And it's dynamic. And so each one of these numbers would have been calculated by taking the number to its left and dividing by 1 plus the discount rate to whatever the n is, and you got the n as the years here. And then here we've simply got a running total of all of that. Now notice that in this running total, we aren't taking this cash flow in year 0 into effect. Why not? So the answer is, I love answering my own questions, by the way. That way I know I get them right, okay? The answer is because in this column, we're putting together the sum of the present values of the discounted cash flows from the company, trying to come up with some present value of the company, right? Is this $20 million cash flow the company's cash flow? It's not, is it, Michael? It's the investor's cash flow. So that's why we have left it out of here. In fact, the only reason I put it in here is to show you guys that it happens at time 0. It's the only reason.
Hey,
Well,
Rick.
this column's running total. Yes.
Hey, Rick, just a question about the cash flow column and then how it relates. So this is kind of a check the box question, but I want to make sure I understand the assignment. So I understand what you said at the beginning about, okay, you've got your negative numbers and then all of a sudden it jumps up to a positive number because you've got those tiered growth rates, by year. But I guess when I tried to calculate that, I got a different number. Is that cash flow column just supposed to be given? Because I calculated everything else correctly.
So when you say calculated that, which is that, Matt?
Sorry, so I calculated the present value of the discounted cash flows and the sum of the present value of the discounted cash flows. But I used the cash flow column, years 0 through 13 to do that. I couldn't, basically calculate the cash flow column starting with my investment.
So you used
I expected to do that.
You used this column rather than this column?
The jump, I feel like I had the same problem as you, Matt. Like, I could figure them out, but I couldn't figure out the year 4 because you make this jump from a negative to a positive, and you can't do.
If you times negative 5 million by 35%, you get negative 1.75 million. So I guess my question is just simply, am I supposed to calculate the cash flow column, or is it given?
So in this case, you're told that there is a negative cash flow in year 2016, right? And then you're told that that grows at a 0% rate. So negative 5 million times 1 plus 0.0 to the first power is what? It's still negative 5 million. Okay, so whether you did this formulaically or just type the number in, you should have gotten the same value. Now, I'll tell you, always do it formulaically. That way, if you changed your assumption here to 1% or 7% or whatever, now you don't have to go back and recode numbers in here. The work's been done for you. And then you're told again, and you pointed this out, that there's this big jump. You go from this $5 million loss to a $3.5 million positive cash flow. Well, that is a break, right? And if you were just given the rates to calculate that, you wouldn't be able to. You're going off of another piece of information here, which I believe is found down here in the footnotes. Okay? This one is purposely complex to help you see, like the others aren't, right? But to help you see that our cash flow changes aren't always as fluid or as consistent as we might like them to be. If I gave you the rest of the backstory on this company, it projects a loss of $5 million a year for each of the next 3 years, after which point a federal contract kicks in, and it will help it have a $3.5 million positive cash flow that grows at a contractual 35% for several years. The only reason I would believe that story is the term federal contract. In fact, in this case, it's a defense contract. Okay? Does that answer your question, Matt?
Even in the
No, it does not.
The thing is that the 3.5 million, we couldn't figure out where that came from.
Yeah, where does that come from?
And you couldn't find it in the other components. So that's why we were on the chat, we were trying to figure out where that came from. And we just assumed that that was a number that was given.
Given, yeah.
Yeah, I'm looking for it. It's in here. Hang on.
So I think Matt's question was whether the cash flow numbers are given, or do we need to calculate them?
We should have been able to calculate them all if we should have been able to calculate them all if we had the 20 million, we had the 5 million, we understood that. But the 3.5 million, that's the only one that you needed to calculate the rest. If you didn't have that, then it was hard. So then that's where we were trying to figure out that one. Everything else from 2019 forward, we were able to do that with the
right. And I'm seeing here that somewhere through the various translations of this, and modifying it for different dates and groups, that $3.5 million figure has not been expressed anywhere else. And so that should have been expressed somewhere in here as a given for that particular year.
Okay.
It was initially somewhere. It has been changed in one of the various incantations of this.
So just to clarify, and then that's fine if that is, just so I understand from a just cash flow perspective. So the idea was, what the problem was, if you were given just that figure, then if you understand the model and the calculation of how it works, you should be able to extrapolate the rest of those cash flows using the time value money, formula, basically timesing those cash flows by their growth rates for their given periods.
You're exactly right, Matt.
Okay.
Exactly right. So everything else on here becomes formulaic, and you should then be able to come up with these numbers. Now,
so Rick, can you highlight again what are the numbers that are given and the other ones that we have to calculate, please?
So this number,
okay,
given, this number, and this number.
Perfect. Okay. Thank you.
And in fact, actually, the 5 million and the 20 million, you can read about them. You can see that they're given, but that the positive 3.5 million, somehow that is no longer part of the story here. I'll have to reintroduce that to the story. I don't know how it fell out, but it's almost certainly something I inadvertently took out, and I apologize. Okay, so what other questions do you have about what's going on here?
Yeah, so just trying to understand the concept of discounted cash flows better. And so just going back to free cash flow for a second. So if I understand, the reason we actually boil things down to a free cash flow to begin with, we look at the formula, is you have a business, you've got all these capital components, you got money coming in and out, you've got revenue, then you've got profit, then profit is distilled down into a more pure value, which is free cash flow, right? That's why we're going to measure it that way, because it's an even purer way to evaluate something, than just operating income or even profit, right?
So Matt, our conception of profit is largely driven by thinking about net income.
Right.
Okay, which happens to be an accounting artifact and is not a cash flow value. And it's tainted by discretionary decisions. I know it's not a cash flow value because to get to net income, I subtracted depreciation, but I never wrote a check for depreciation. It's not a real number. And so colloquially, and through all of our various accounting classes, we've been fooled into this expectation that profit is net income, when in fact it is not. For us as investors, business owners, managers, profit, if you will, is better termed as cash flow, or the cash that we have available to do something with. And the technical term for that is free cash flow, and from the equation that we create.
That's why we take out the capital piece when we do the calculation, right? That's why we're taking out net capital spend and changes, because those are not only, like you said, accounting artifacts that are on the balance sheet, but those are tied to those discretionary decisions, whereas free cash flow is not necessarily.
They are tied to some decisions of management, but without those decisions, we would never get the cash flow. So those capital components, change in net working capital and net capital spending, represent commitments we as management have made with some of the cash flow that will come from the company in order to execute the plans that we have put in.
Oh, okay. I gotcha. So it's just, it's like almost like we have to subtract it because it's a part of cash flow that technically is earmarked.
It's kind of like every month, I'm going to guess in your household, you get a paycheck or two. And you know that maybe that paycheck or two is even strong enough that you got $10,000 of net income that came into your household. But you'd be nutso to spend all $10,000 because you've got a house payment, You got to buy food. You might have a household to support. There might be children. There might be medical bills. There might be credit cards. That is not your free cash flow.
Right.
Think of it in that respect, and that might help you a little bit with it. Okay.
Yeah. No, that totally makes sense.
We've got to come back to the conceptualization of how a business creates value for its owners. And that is, a business is only as valuable as its free cash flow over time is given to the owners. But we know that because it's given over time, we need to find a present value of that cash flow. Because a cash flow of, let's say, $18,722,616 a whole bunch of years from now isn't worth that to me today. In fact, if I have a discount rate of 20%, that's a big discount rate, then that $18,700,000 is worth less than $1.8 million to me today because of discounting for rate and time. So what is a business worth, or what is a particular project that you might employ in a business worth? The present value of all of its expected future cash flows. So we've got to add them all up for the explicit period that we know about and we've credibly forecast, and then we've got to find the rest of them using some other construction, and in this case we use the Gordon growth model construction, and then we add it up. Okay? So again, you can take just the numbers on their face value, or you can go ahead and construct a spreadsheet. I've gone ahead and constructed a spreadsheet, which I'm sure shocks you. And if you do this, you'll notice here, like with these numbers, that I'm letting them grow. Well, the ones I had to take as regular input, I took. I just typed them in. But the ones that I could calculate, I calculate.
And those growth rates are just basically an example of a growth. We talk a lot about different rates so far in this class. Sometimes they're based on the market. Sometimes they're based on a lot of different factors. In this model, we're just using rates that are kind of hypothetical based on the scenario, right? Like we've estimated that that's going to grow for these amount of years at 35%.
Yes, and part of what we're going to do tonight is take a critical look at how we come up with these estimates. We'll look at estimated growth rates, and then we'll look at growth rates of revenue, and then we'll look at the growth rate and change in expenditures so that we can figure out our future year's EBITs. And if we know our future year's EBITs, we're off to the races.
And just one other question about present value. So let's say, just for example, what you have pulled up there, let's say that first positive figure, 3,500,000 on row 13 there. So just to understand what present value means in relation to a future cash flow, or sorry, a free cash flow. So you're saying to me that, okay, I projected based on this growth rate, based on all these other factors in my capital model, that I'm going to have in year 4, 3,500,000 in free cash flows. But that means that it's going to cost me to get to that today, that present value number of right next to it?
No, you're close, Matt. So you were right up to the figuring out the $3.5 million, but the number to its right, 1,687,000, is what that $3.5 million is worth to you today. So if I give you $100 5 years from now, it's not the same thing as giving you $100 today, is it?
No.
Inflation's going to eat away at it. Your ability to have used it in the meantime will not have been enjoyed, etc. So $3.5 million in 4 years for somebody with a 20% discount rate is equal to $1,687,000 today. Let me put this in a slightly different term that might make a little bit better sense. Let's assume that we're talking about inflation instead of some big investor discount rate of 20%. What's a realistic inflation rate Diana. Any ideas? Bella, any idea about what inflation's been running or what realistic inflation might be?
3 to 4%.
How much?
3 to 4%.
That would be a much bigger number we've seen for a while, but let's use that. Okay, so an inflation rate is a type of a discount rate. Well, in that case, if I came to you, Jason, and said, which would you rather have? $3,500,000 in 4 years, or knowing that money is going to change value, be inflated at 3%, $3,109,000 today. Which would you rather have?
I got to see what is 3% of 3 million, and then do that over 3 years, and whatever that value is.
Yes, but if you had done that, if you could quickly process that, and most of us human beings can't unless you pull out the calculator kind of thing, you would probably say, well, Rick, it doesn't matter to me because they're the same number. One of them in today's value, and one of them is a future value. They're the same number. Okay. Now, if I came to you and if you knew that the present value of $3.5 million today, or the present value of $3.5 million in 4 years, if you knew that was $3,109,704, if I offered you $3 million instead of $3,109,704, which would you rather have? $3 million today or $3.5 million in 4 years? Lisa, which would you take? $3 million today or $3,500,000 in 4 years?
I'd take today.
I would take 3.5 in 4 years.
Why, Diana?
Because in the future we'll get 3,109,704, so it's a little bit more than 3 million.
Yeah, and it's not that you would get it in the future, it's that that's what $3.5 million in the future would be worth to you today.
Oh, I get what you're saying.
Okay.
So it would cost me 3.1 million in the future to get that 3.5 million, versus
it would
instead of
3.1 today to get the 3.5 in the future. Okay. I'm going to put this back to the 20% where it belongs. Okay. The using CAPM and WACC problem set is all about causing you to set up these various cash flows and recognize the dynamic effect of different discount rates. What it's all about. Okay? Any other questions you might like to ask with respect to it? Okay, let's move on to the Excel assignment then.
I'm sorry, Rick. I thought you meant just for that section. Can I ask a question about that number 9?
Certainly. Hang on just a second to go back there.
I apologize.
No, not at all. Number 9. Let's see what that is.
So I understood this. Definitely, I understood why there was that discrepancy. My question is where these MPVs are coming from.
Got it.
I thought the MPVs were a little bit different from when I calculated them.
So Mario, when you say different, how much different? Different by a couple of bucks or by some millions?
By millions.
Okay.
Because I thought it would be the 15 million, to be honest, and then I even added year 14, and then it was, I don't know, let me see.
Are you coming up with the same present values?
Yes.
Okay, so let's just look at this one. So if the present value of the company's expected future cash flows are 147,859,000 and some change, and if we were lucky enough to be able to buy that for 20 million bucks, what's the net present value? We take the present value of the benefits, which we just articulated at 147,859,000, minus the 20 million, which would give us then the 127,869.
Okay, got it. Thank
you. So if you're coming up with a different net present value, look at the equation that you're using to come up with it.
Okay. No, that makes sense. I got it now. Thank you.
With me? Okay.
So, And then did you just calculate 2,163,342 from the second model? Did you calculate that?
Yeah, in fact, I didn't even go from the second model. So I could have though, Diana. So I give you right on the front page. Present value is 22,163,342. That's the outcome of all of this stuff. Now maybe I have you replicate that, but it's the outcome of all of this stuff. Well, if you know that that's the value, the present value of the expected future cash flows, and if you know it's going to cost you $20 million to get them, what's the net present value? Well, 22,163,000 minus 20 million, which is, not coincidentally, 2,163,000. Okay. Net present value, as we went over it in the first time we talked about it critically, can be in a very easily calculated value. If you know the present value of the firm, the value of the asset, you know what it's going to cost you to buy it, the net present value is the difference. You're netting out the cost against the benefits. Easy enough. Or you can use one of the somewhat more complicated equations to do it. We'll look at those again in just a moment when we look at the spreadsheet. What other question about other elements of this problem set before we move to the Excel assignment?
I am still having a little bit of trouble understanding what we were talking about through WhatsApp, where with the lower rate, you have a higher value.
Okay.
And I do understand it in the sense that you were explaining, like, if you have a set cash flow, then you would need to buy it or value it at a lower cost. So buy it at a lower cost in order to reach it with a higher rate. Like that, I understand. I guess I just don't understand, like, logically how that makes sense. How, like, something that would take longer to reach that cash flow because it has a lower rate would be valued more.
So you actually, Kate, understand the hardest part of it.
Okay.
So I want to walk you through the two somewhat simpler elements for a minute. Okay. And I have to bring up a different document to do that, so bear with me just one moment, please.